Today I'm going to be talking about 1.4 in Hurley's Intro to Logic, the section on evaluating arguments. Again, there will be 3 quiz questions at the end of the video, so make sure you're taking notes and you have pen and paper handy. So let's start today by talking about 2 ways that arguments can go wrong. So look at this first argument. Either G.W. Bush or Bill Clinton was president on 9/11/01. G.W. Bush wasn't, therefore Bill Clinton was. Now there's something clearly wrong with this argument. Something must have gone wrong to get to that conclusion. So let's look at what went wrong. So what clearly went wrong was premise 2 is false, right? So premise 2, the reason that the author gives here, that George W. Bush wasn't president on 9/11, that's just a false claim. So that's one way that arguments can go wrong. They can have a premise that's false. Then take a look at this other argument. Steph Curry is the greatest shooter in NBA history. Therefore, Steph Curry is the greatest player in NBA history. Now, this argument doesn't seem to go wrong in the same sort of way that the first argument did. Premise 1 is probably true. If you doubt the truth of that premise, you can read this awesome article on 538, and you'll see that in all these graphs about shooting efficiency and volume, here's Steph Curry way up in the upper right, nearly off the chart. So this premise, unlike premise 2 in the first argument, premise 2 in the first argument was false, this premise seems to be true, that Steph Curry is the greatest shooter in NBA history. But the conclusion that's drawn from that is he's the greatest player in NBA history. Now something seems to have gone wrong, because while the premise seems very clearly true, the conclusion is very controversial and, to be honest, probably not true. So what did go wrong here? Well, one thing we could say is, even if it's true that he's the greatest shooter in NBA history, that doesn't give us enough support for the claim that he's the greatest player in NBA history. The reason for that is there are other things that are required to be the greatest player in NBA history. You'd have to be a very good rebounder, a great passer, a great teammate, a great defender, all of those sorts of things. So even if it's true that he's the greatest shooter, that doesn't give us enough support for the conclusion that he's the greatest player in NBA history. So to review 2 ways that an argument can go wrong: a premise can be false, or even if the premises are true, they could not give us enough support for the conclusion. So that leads us to 2 questions that you need to ask of arguments to evaluate them. The first question: if the premises were true, would they provide enough support for the conclusion? Let's look back at our 2 examples here. As we discussed in the second example, even if the premise was true, it wouldn't give us enough reason to believe the conclusion. But let's look at the first argument in light of that first question. So if it was true that either Bush or Clinton was president on 9/11, and if it was true that Bush wasn't, would those premises give us enough reason to believe that Clinton was? And the answer to that is yes, right? Even though premise 2 is untrue, if it were true, and if premise 1 was also true, then we would have good reason. In fact, it would be guaranteed that Bill Clinton was president if those premises were true. So this first argument passes the first question, gets a yes on the first question. The second argument gets a no on the first question. But then there's another question we need to ask. Are the premises in fact true? So what the statements tell us is, do they match up with the world, right? So in the first argument, we saw that the first premise is true, second premise is false, so this argument goes wrong because one of the premises is false. And the second argument, the first premise is probably true, so it doesn't go wrong in that way, it goes wrong in the other way. So, if an argument is good, then the answer to both of those questions, if the premises were true, would they provide enough support for the conclusion? And are the premises true? If an argument's good, the answer to both of those questions will be yes. If the answer to either question is no, then the argument is bad. We'll get some more specific vocabulary for saying good and bad for arguments in fancy ways, which indicate the different ways that they can go wrong or the way that they can go right. So, looking back at question number 1, I've underlined a word here. I've underlined the word enough. And that's because this question, if the premises were true, would they provide enough support for the conclusion? That the standard that we have for enough, for the kind of support that we would need to answer that question yes, changes whether we're talking about an inductive or a deductive argument. Recall in the last video we talked about deductive arguments, and for deductive arguments they're trying to prove their conclusion with certainty. So for a deductive argument, the way we ask question 1 is, if the premises were true, would they guarantee the conclusion, right? Would they make us certain of the conclusion? For an inductive argument, we have a different standard. For an inductive argument, we ask, if the premises were true, would they make the conclusion more likely than not? So the two different standards, to answer that question yes for a deductive argument, the premises would need to guarantee the conclusion. To answer that question yes for an inductive argument, the premises would need to make the conclusion more likely than not. So now let's talk about some vocabulary in this section. So, for a deductive argument, if this is referring to the first question again, if it's the case that if the premises were true, then the conclusion would have to be true, then we call that argument valid. Now note that validity has a very narrow definition in logic. You may hear this word in popular speech where somebody might say, oh, you make a valid point, meaning you make a good, like true or relevant point. That's not what the word valid means in logic. In logic, validity is a property of arguments, not statements. Specifically, validity is a property of deductive arguments, where if the premises were true, then they would guarantee the conclusion, right? If it's not the case, so if it's the case that if the premises were true, they would not guarantee the conclusion, then we call that argument invalid. So if they were true, if they would guarantee the conclusion, valid. If they were true, they would still not guarantee the conclusion, invalid. All right, so that's one, a good property of a deductive argument, validity, a bad property of a deductive argument, invalidity. But now, the best way a deductive argument can be, the best way it can go is if it's valid. So if the premises were true, then the conclusion would have to be true. And if all of the premises are in fact true, then we call that argument sound. So if the answer, recall, we're dealing with both of those two questions we talked about at the beginning. If the answer to both those questions is yes, so if the premises were true, they would give enough support for the conclusion. In this case, guarantee it. And if the premises were in fact true, the answer to the question dealing with that was yes, then we would have a sound argument. Now, what would we know about the conclusion of a sound argument? The conclusion of a sound argument would have to be true, right? Because a sound argument is a valid argument, so if the premises were true, then the conclusion would have to be true. And the premises are in fact true. So a sound argument has a true conclusion, right? It has all true premises, it has a true conclusion, and the truth of the premises guarantee the conclusion. All right, so best case scenario, right? A valid argument with all true premises. That's ideal. Now there's many ways a deductive argument, or a couple different ways, a deductive argument can fall short of that ideal. If either the argument is invalid, or it has an untrue premise, or multiple untrue premises, or both, then the argument's unsound. So an invalid argument is automatically unsound. An invalid argument with not true premises is certainly unsound. And even a valid argument, if the premises are not true, that would also be unsound. So there is one way that a deductive argument can go right, and there are a few ways that it can go wrong. Now, we have a similar breakdown for inductive arguments with some different terminology. So for an inductive argument, recall that first question we asked, if it's the case that if the premises were true, then the conclusion would likely be true. And what we're looking for there is more than 50% probability. Then we'd call the argument strong. If it's not the case that even if the premises were true, if it's the case that even if the premises were true, they would not make the conclusion more than likely, then we call that argument weak. So recall, again, these qualities we get to by asking the question, if the premises were true, would they provide enough support for the conclusion? For inductive arguments, enough means make the conclusion more than 50% likely. So if that is the case, then the argument is strong. If it's not the case, weak. Now, just like for deductive arguments, the best sort of deductive argument is a sound argument. The best sort of inductive argument is a cogent argument. So if the argument is strong, so the truth of the premises would make the conclusion more than 50% likely, and the premises are in fact true, we call that argument cogent. And then there are a few ways that an inductive argument can go wrong. It can be weak. If it's weak, it's automatically uncogent. If it has an untrue premise, then it's probably uncogent. And both could be the case. So if it's weak and has an untrue premise, then it will certainly be uncogent. So let's look at sort of a flow chart of this. Zoom in here. All right, so on the left-hand side, we have deductive arguments. On the right-hand side, this infographic says non-deductive. Let's just substitute the word inductive over there for our purposes. So we have deductive arguments on the left, we have inductive arguments on the right, and you'll see the path that both would have to take to be good arguments up at the top. And some ways that they can fail to be good arguments and be, end up being bad arguments at the bottom. So the good arguments rise to the top, the bad arguments we throw way down at the bottom. So for a deductive argument, if it's invalid, it's automatically a bad argument. If it's valid, but has false premises, that's another way it could fail and be a bad argument. The only way it succeeds is if it's valid, has true premises, and then it's a good argument, and we call that sound. On the other side of the chart, if we have an inductive argument, and if the inductive argument is weak, so the truth of the premises would not make the conclusion more than likely, then it's already a bad argument. Now, if it's strong, but then has false premises, then it's still going to be a bad argument. But if it's strong and has true premises, then climbs all the way up the ladder, good argument, and we call that cogent. So note the ways that arguments can fail to be good. There's a couple of them here. And the ways that they can be good. So there's only one path for a deductive argument, one path for an inductive argument to be a sound or cogent argument, respectively. All right, so now let's talk about the specific types of arguments that we covered. In the last section, we covered different types of deductive arguments and inductive arguments, covered 5 types of deductive arguments, so arguments from math, definition, and then 3 different types of syllogisms, categorical, hypothetical, and disjunctive. And then for inductive arguments, we covered predictions, analogies, generalizations, arguments from authority, arguments from signs, and causal arguments. So let's look at each of these and talk about how we could figure out if an argument is valid for the deductive arguments and how we can figure out if it's strong for the inductive arguments. So first, let's look at arguments from math. So with arguments from math, if the answer is right, then the argument's valid. If the answer is wrong, then the argument's invalid. So look at the valid argument here. So we get 3x plus 1 equals 10. Therefore, x equals 3. So we would solve for x there, and x would equal 3. So if 3x plus 1 equals 10, then x would have to equal 3. So if that premise is true, then the conclusion would be guaranteed. So that's a valid argument. Going over to the invalid argument, 3x plus 1 equals 10. Again, x would have to equal 3 there, but the answer here says therefore x equals 5. Well, if 3x plus 1 equals 10, x cannot equal 5. If x equaled 5, then 3x plus 1 would be 16. So that's an invalid argument, right? So for mathematical arguments, if the answer is right, then the argument's valid. For arguments from definition, if the definition of the word is used correctly, then the argument is valid. So take a look at this argument. Bob is an atheist, therefore Bob believes no gods exist. Well, that's what being an atheist is. It means you don't believe in any gods. So that would be a valid argument. If that premise is true, then the conclusion would be guaranteed. An invalid argument would be Bob is an atheist, therefore Bob believes Zeus exists. Even if that premise is true, it certainly would not guarantee that the conclusion is true. It wouldn't guarantee the conclusion is true because the conclusion would be false. So that would be an invalid argument. Then we get our 3 different types of syllogisms. So we'll just briefly cover 2 of these. We'll briefly cover categorical syllogisms. We'll briefly cover disjunctive syllogisms. We'll go a little bit more in depth with hypothetical syllogisms. So first, categorical syllogisms. First, it's the topic of an entire chapter in our text, chapter 5. So if you want to get deeper into categorical syllogisms, then you can check out chapter 5. But look at this first valid example. All sharks are fish, all fish are friends, therefore all sharks are friends. Now that's a valid argument. If it was true that everything that was a shark was also a fish, and everything that was a fish was also a friend, then it would follow that all sharks are friends. An invalid categorical syllogism, all sharks swim, all whales swim, therefore all sharks are whales. Now, even if it was true that all sharks swim, and even if it was true that all whales swim, they are in fact true, the conclusion certainly would not be guaranteed. So here we'd have an invalid argument. One thing the chapter makes a big deal of is if you have a deductive argument where the premises are true and the conclusion is false, then you know you have an invalid argument. The book makes a big deal of this. It says it's the most important idea in all of logic. So I'll point that out here. We have true premises and a false conclusion with a deductive argument, so it had to be invalid. All right, so like I said, we'll go a little bit more in depth with hypothetical syllogisms. So there are some valid forms. Recall that for a conditional statement, all hypothetical syllogisms have conditional statements as premises and sometimes as a conclusion. A conditional statement, there's an antecedent, that's the part after the if. And then there's a consequent, that's the part after the then. So valid forms, affirming the antecedent, denying the consequent, what we call a pure hypothetical syllogism. And then there's some invalid forms, denying the antecedent, affirming the consequent, and what I'm calling an impure hypothetical syllogism, because I couldn't find a better name for it. So let's look at the chart here. So on the valid side, we have what I called affirming the antecedent. And the form of that looks like this. If A, then B. A, therefore B. So the part after the if is the antecedent. So we have a conditional statement for premise 1. And then premise 2 affirms the antecedent. So if A, then B, premise 2 tells us A is the case, and therefore we conclude that B must follow. So an example, if Freddie is a dog, then Freddie is a mammal. Freddie is a dog, therefore Freddie is a mammal. Recall that in 1.2 we talked about conditional statements, their parts, antecedents, and consequents, and how the antecedent was a sufficient condition for the consequent, while the consequent was a necessary condition for the antecedent. So, if the antecedent is true, then that's enough to know that the consequent is true. So, if Freddie is a dog, then Freddie is a mammal. Well, if we know that Freddie is a dog, then that's enough to know that Freddie is a mammal. So, if we know that antecedent is true, then that's sufficient for knowing that the consequent is true. Another valid form is denying the consequent. So we can affirm the antecedent or deny the consequent. Those are valid forms. So here again, in premise 1, we have a conditional statement, if A, then B. And in premise 2, where the argument gets its name from, denying the consequent, we see the consequent denied. So it's not, B is not the case. Therefore, we conclude that A is not the case. Recall again that the consequent is a necessary condition for the antecedent. So if the necessary condition is not met, then we know that the antecedent is false. So look at the following example. If Freddie is a dog, then Freddie is a mammal. So we have that same conditional statement. But the second premise, it's not the case that Freddie is a mammal, denies the consequent. And since being a mammal is a necessary condition for being a dog, you have to be a mammal in order to be a dog, then it can't be the case. If Freddie isn't a mammal, then he can't be a dog, right? So the necessary condition is denied, so the antecedent can't be true. Then we get some invalid forms of hypothetical syllogism. So we can deny the consequent for a valid argument, but if we affirm the consequent, we have an invalid argument. So we have if A, then B, conditional statement, and then the second premise, B, affirms the consequent. Therefore, the conclusion, the antecedent. So the example, if Freddie is a dog, then Freddie is a mammal. Freddie is a mammal, therefore Freddie is a dog. Now, hopefully it's pretty clear that this is an invalid argument. Because being a mammal, while being necessary for being a dog, is not sufficient for being a dog. So just because we know if Freddie is a dog, then he's a mammal, and he's a mammal, we cannot conclude that he's a dog. He could be any other kind of mammal. Similarly invalid, denying the antecedent. So we get the same conditional statement, if A, then B. And then the second premise denies the antecedent, so it's not the case that A or not A. Therefore, take the squiggly out of here, we'll be introduced to that later. Therefore, not B. Therefore, not the consequent. So, looking at our example again, if Freddie is a dog, then Freddie is a mammal. It's not the case that Freddie is a dog. Therefore, it's not the case that Freddie is a mammal. Now that argument, hopefully again, it's pretty clear that that's invalid because being a dog, while sufficient for being a mammal, is not necessary for being a mammal. So just because we know if Freddie's a dog, then he's a mammal, and just because we know he's not a dog, that doesn't mean we can conclude that he's not a mammal. So we denied the sufficient condition, but it's not necessary for the consequent to be true. So that will also be invalid. So a couple valid forms, a couple invalid forms. Then we get hypothetical arguments where there are three conditional statements that make up the argument. So in those four previous types of hypothetical syllogisms, we had one conditional statement and then two sort of straightforward statements, non-conditional statements. In these two types of arguments down here, we have three conditional statements which make them up. So look at this form. If A, then B. If B, then C. Therefore, if A, then C. That's a valid argument form. So let's substitute some terms in there. If I have $6, then I have at least $5. And then going to the second premise, if I have at least $5, then I have at least $4. And the conclusion, therefore, if I have $6, I have at least $4. That follows from those premises. So that's valid. Then let's look at an invalid form with three conditional statements. If A, then C. If B, then C. Therefore, if A, then B. Now that's an invalid argument. Let's put it this way. If I have $5, then I have $4. If I have $6, then I have at least $4. Therefore, if I have $5, then I have at least $6. Then I have $6. That's not the case, right? So that doesn't follow. That's an invalid form. Any argument that had that sort of form would be invalid. All right, for disjunctive syllogisms, there's a valid form denying a disjunct. In fact, at the beginning of this lecture, we had the valid form denying a disjunct. So we had a disjunctive statement. We had either Bush or Clinton was president on 9/11. And then the second premise denied a disjunct, so it wasn't Bush, therefore it was Clinton. And that's a valid argument form. If those premises were true, then the conclusion would be guaranteed. Then we have a couple other forms, another valid form affirming an exclusive disjunct and an invalid form affirming an inclusive disjunct. I'll just put those names here as placeholders for now. We won't be covering them very much until later. Okay, so much for deductive arguments and validity. Now let's look at inductive arguments and talk about when they're strong and when they're weak. So for a prediction will be strong if most of the past events occurred the way the conclusion says the future event will occur. So we had an example argument in the problem sets that we just completed that said something like if the rainfall in Seattle was over 15 inches for the last 10 years. The rainfall in Seattle was over 15 inches for the last 10 years. Therefore, the rainfall in Seattle will be over 15 inches next year. Since 10 out of the last 10 years it was over 15 inches, it makes it very likely that it will be over 15 inches the following year. So that would be a strong argument. If, on the other hand, it said in 3 out of the last 10 years, the rainfall in Seattle has been over 15 inches, therefore the next year will likely be over 15 inches, that would not be a strong argument. That would be weak. For analogies, they'll be strong if there's an important connection between the stated similarities and the conclusory feature. They'll be weak if there isn't an important connection, an important strong connection between the stated similarities and the conclusory feature. So let's talk about some examples. So if I had a red strawberry and I said the strawberry is red and it's delicious, and I had a red apple and I said this apple is also red, and I concluded therefore this apple is likely to be delicious, then that would be a pretty good argument, right? Because there'd be a whole bunch of similarities between the strawberry and the apple, including that they're fruits. So not only are they red, but they're red fruits. One's red and delicious, the other also red, probably delicious. But if I was talking about the similarities between my red strawberry, so the strawberry is red and delicious, and a chair, and said that chair is red, therefore that chair is probably delicious, then there wouldn't be that strong connection between the similarity of being red and the conclusory feature of being delicious, so that would be a bad analogy. So the analogies will be strong if there are good similarities between the things, many and good similarities between the things. It won't be strong if the similarities are sort of what we might say surface similarities. Right, moving on to generalizations. An argument from a generalization will be strong if the sample size is sufficiently large and diverse. It'll be weak if the sample is small and not diverse enough. So for generalizations, think about and thinking about samples, right? So you go to an ice cream store to get a sample of an ice cream. Say you want to try the Rocky Road ice cream, and they give you a sample. You ask for a sample, they give you a really small scoop of the Rocky Road. They just give you a little bit of the chocolate ice cream without any of the nuts or marshmallows or anything. You might say to them, that sample is too small, that sample is not diverse enough, so it doesn't give me a good idea of what the ice cream would taste like. Whereas if they gave you a pint of the Rocky Road ice cream and they asked you to draw a conclusion about how you would feel about the ice cream based on that pint, then you could make a good generalization, right? I like this sample, therefore I'll probably like the entire vat of Rocky Road ice cream. An argument from authority. So recall, an argument from authority is structured such that the premise is about something someone says or has written, and the conclusion is drawn that what they said or wrote must be the case. So they're strong if the authority is credible in making a claim within their area of expertise, and it's a weak argument if either of those things is not the case. So if the authority is incredibly biased, if the cited supposed authority is not an expert, or if it's an expert or making a claim not in his area of expertise, then that's going to be a weak argument. Evaluating an argument based on signs is very similar. So it's strong if it's created or placed by a reputable authority. So a sign that you might see, like a road sign, would give us a good indication of what it's saying. A sign in a museum would give me a good indication of what it's saying. Whereas something scribbled in chalk on the street, that wouldn't make it likely that what it was saying is true. And like a bumper sticker wouldn't give me a good indication that what it's saying is true. Finally, causal arguments. Determining whether a causal argument is strong or weak is a really big issue. We'll cover it more thoroughly in Chapter 3. I'll try to refrain from giving you examples on homework or the test. And if there is an example of a causal argument, just give it your best shot. So, all this being said, let's review a little bit. Recall, for when we want to evaluate an argument, there are two questions we have to ask of it. First, if the premises were true, would they give enough support for the conclusion? Second, are the premises in fact true? We reviewed how if the argument's deductive, then we look for a different kind of support for premise one than if it's inductive. So if it's a deductive argument, we're looking for the premises to guarantee the conclusion. If it's an inductive argument, we're looking for the premises, if true, to make the conclusion more likely than not. We covered some vocabulary regarding arguments, validity, invalidity, soundness, for deductive arguments, for inductive arguments, strength, weakness, and cogency. And then we looked at some specific forms and how to apply, or how to figure out if a deductive argument is valid or invalid, and an inductive argument, whether it's strong or weak. All right, so now on to some quiz questions. So, is the following argument valid, invalid, strong, or weak? Either Shaun White or Scott Lago won an Olympic gold medal in 2010. Shaun White did not win one in 2010. thus Scott Lago did. So remember, to answer this question, you'll have to first determine if the argument's deductive or inductive. Then then you'll have to go into some further considerations to see if it's valid or invalid, strong or weak. Quiz question 2, is the following argument valid, invalid, strong, or weak? If stun guns are safe, then police officers will use them. Stun guns are not safe, therefore police officers will not use them. We went really in depth with hypothetical deductive arguments. This is an example of one. So you might want to look back at the work we did with hypothetical syllogisms to see if this is a valid argument, or invalid, or strong or weak. And quiz question 3. Given that the premises of the following argument are true, Yep, that's the same quiz question. All right, only 2 quiz questions for this chapter. Next time we'll go back to doing 3 quiz questions. So, just the 2 quiz questions. Make sure you do that on Canvas before our next class. And next time, we'll go over another chapter.